Hi guys, this is Mr. Richard. So in this video, we are going to work with Mathematics Paper 2, November 2022, National Senior Certificate. Yes, for South African learners who are doing CAPS, right. We are working with Mathematics Paper 2 as I've stated. Right, which is out of 150. But in this video, we are going to work with question 5, right? Let's take a look. At question 5, we have what we call trigonometry. Specifically, in this video, we are going to look at trigonometry, right? First thing first, we have a diagram question there at 5.1. Given that root 13 sine x plus 3 is equated to 0, where x is an element of 0 and 90 degrees. How many marks is that? That's 2 marks, right? Okay. Then, without using a calculator, determine the value of. Right, let's put this into practice. As I've stated, remember that we are working with question 5. At question 5.1, this is what we got. Root 13 sine x plus 3 equated to 0. And we are given a restriction where x is an element of 0 degrees and 90 degrees. So meaning that our diagram will be on the first quadrant. Okay, let's put that into practice. The diagram will have something like this. On the first quadrant, it's 90 degrees. And we know that 0 degrees and 360 here. Okay, right? So we need to make this in a, okay, we need to make sine x the subject. So what we are going to do, we are going to say root 13 sine x. We are going to transpose 3 to the other side. It becomes negative 3. What you should note is that on the first quadrant, this is where all the trigonometric ratios must be positive. And also what you should note is that the y values here are positive and the x values here are positive. There's nothing that is negative in this case. Okay, let's divide by root 13. Let's divide by root 13. Okay, we are left with sine x, which is equals to negative 3 all over root 13. Way. What am I seeing? Yeah. Oh, there's an error in this question. We can't have a negative thing here. Why am I saying so? Let's say you were having a terminal angle here, maybe theta. Your opposite side will be in this case. So meaning that this will be negative 3 and root and the longest side, which is the hypotenuse. And here it will be our x, which is we don't know, which is an adjacent side. So we can't have a negative value here. Our opposite can't be negative in this case. So that makes this thing wrong. There is an error in this situation. There is an error, guys. There is an error, meaning that this question, we have to leave it. Okay. What if maybe in the memo here it was supposed to be minus, or yes, maybe it's written like that. So if it was positive, we will write it like this: root 13 sine x, take 3 to the other side, this will become positive 13. We will then divide both sides by root 13, divide both sides by root 13. Then we will have a positive 3, not a negative 3. This doesn't work. That means it's incorrect. So if it was a negative in that case, we will have something like this as 13 or 13 So to get the adjacent side, we will use a theorem of Pythagoras. As you know, x squared plus y squared is equals to r squared. Then we'll make the hypotenuse, the adjacent, the subject. Then this will be minus y squared. What is our r? Our r is root 13 squared. What is our y? Our y it's 3 squared. Squaring the root we'll get rid of the square root, so we'll be left with 13 minus 9 squared, right? 13 minus squared, what is that? That is 4. And then square root of 4, it's plus or minus 2, but we'll take the one that is positive since we are working on the first quadrant. So in this case, it was supposed to be x is equals to 2. Then the first question was saying that we need to find the value of sine x, sine 360, sine 360 plus x. Sine 360 plus x is on the first quadrant. It's in this case, it's on the first quadrant, or where all the trigonometric ratios are positive. So meaning that we will have sine x if it was in this case. But remember, guys, at 5.1, there is completely an error there, right? Okay. All right. So this is meaning that if it was negative in this case, we will have 3 root 13. Okay. So the next question was saying, without using a calculator, determine the value of tan x. Tan x. Remember that tan x is opposite all over adjacent. Our opposite, remember that we got 3 and our adjacent was 2. So we will have something like 3 all over 2. So if the other one was saying cos 180 plus x, which is a home for, remember that when you're using cast diagram, 180 will be 180, this will be 180 minus x, and this will be 180 plus x. The third quadrant, it's not a home for cos, it's a home for tan. So in this case, we will have negative cos x. So we will have, remember this is a cos is adjacent, so in this case we will have negative 2 all over hypotenuse, which is root 13. So that's how you were supposed to answer 5.1 if they didn't make an error. But in this case, at question 5, there was a what? There was an error. So there was an error. Hope the Department of Education will fix this error. Right, there wasn't completely an error. So guys, let's go to question 5.2. At 5.2, we are required to determine the value of the expression without using a calculator. We are given cos 90 plus theta and cos sine 180 minus theta. All right. First thing first, it's good to know where your function values are located on a cast diagram. Remember? Let's put this into practice. How many marks is that? That's 5 marks. You can't afford to lose such marks. Cos 90 plus theta. Right. Use your cast diagram, guys. Cos 90 plus theta, it's on the second quadrant. And remember that 90 minus theta, it's on the second, it's on the first. And this is where 360 plus theta, as well as we have 180 minus theta. We also have 180 plus theta, and we also have 360 minus theta, and a negative angle. Remember, all science teachers take coffee. This is where sine is positive, but the other trigonometric ratios are what? Are negative. So in this case, we have cos 90 plus theta. How is cos at the second quadrant? It's negative, is it? Yes, but sine is what? It's positive. So in other words, sine will take the sine of cos. Remember that since it's 90 plus theta, it's a cofunction, so it will change. It will change to negative sine theta in this case. So what about this? When you're given sine theta minus 180, what you should do, I advise that you should write this thing in this case. Let's rearrange it. Okay. Advise that what you could do, you can write this as negative 180 plus theta. Sine negative 180 plus theta, it's this is the third quadrant. How is sine at the third quadrant? It's negative. So in this case, we are going to have negative sine theta plus 3. Okay, negative and positive, they will affect this. So we are going to have negative sine theta. Okay, so let's work on this negative sine theta. So these are like terms. So in other words, we have invisible coefficient of 1. So these are like terms. Negative sine theta minus 3 sine theta, it's the same as negative 4 sine theta. Like terms, negative 4 sine theta. So this and this, they will cancel. We'll have the numerator is positive 1. So we're going to have 1 over 4 as our solution there. So this is what you were supposed to do at question 5.2 to get that mark. So that's it, guys. So let's go to 5.3. At 5.3, we are required to determine the general solution of the following equation. How many marks is that? That's 6 marks, guys. All right. So given this type of equation, this might remind you of paper 1. Whenever given such an equation that is equated to 0, or the product of 0, we will equate everything to 0 in this case. Right? We are looking for the general solution of cos x plus 2 sin x and 3 sin 2x minus 1 equated to 0. How many marks is that? That's 6 marks. Let's put that into practice. As I've stated, remember, we are at 5.3. We have cos x plus 2 sin x equated to 0. So, okay, let us put this. We have 3 sin 2x minus 1 equated to 0. Okay, so we will have to take this into brackets, take this out of brackets, then we are going to say cos x plus 2 sin x is equated to 0. So let's work out this first, right? So what you are going to do, you are given cos plus 2 sin x is equals to 0. So in this case, this is what we are going to do. You are going to take sin 2 sin x to the other side. It will become negative sin 2x. Right, so when you're given cos and sine, the aim here, we need to make it a quotient identity. So this will be definitely done. So in other words, we are going to divide both sides by cos x. We are going to divide both sides by cos x. So cos all over cos, that will be 1. Then sine all over cos, that will be 10. So we're having negative 2 10x. So to make 10 the subject, divide both sides by negative 2. Therefore, this definitely will be tan x, which is equals to negative 2. So since we are looking for a general solution, we may use our calculator then. So just say we're looking for the reference angle, second function of tan. So we are not going to put a negative value. Mind your decisions. When you are like in this manner, you are not going to put a negative value. So when you are here, we are not going to put a negative value, we are going to put a positive value. So this will be second function of half, which will be 26,56. Okay, this is what we are having. The reference angle will be 26,5650511. Is it what? The 8, not 3. It's 8. Okay, we'll round off the final answer. So we have to write the general solution. In this case, we are going to have 26. Rounding off, this will be 26,57 plus k times 180 since it's tan, right? So, or we will look where tan is negative. Tan is negative on the second quadrant, so we could say 180 minus 26,57 plus k times 180. So x, so 180 subtracted by 26,57, that will be okay, that will be 153,43. Okay, that will be the case, 153,43. So in this manner, we are going to have 153,53. So that's how you can get this a general solution of this type. So let's go to the second one. For the second one, guys, remember that we have 3 sine 2x minus 1 equated to 0. So the aim here is to take, we are going to have 3 sine 2x, take negative 1 to the other side, it becomes positive 1. You will then divide both sides by 3, divide both sides by 3. This and this cancels. So we are having sine 2x is equals to 1 all over 3. Remember, so when you're given in this manner, we need to make, this will be, sorry for that, 2 sine, this will be 2x is equals to the reference of this. Okay, take your calculator there. So what are we going to have? Sine arc of 1 over 3 sine arc of 1 over 3. So we have 19,47. Yes, so that will be 19,47. So we are going to have 19,47 plus k times 360, since it's sine, the period of sine is 360, remember. So when you're like, when you've written it like this, you may divide both sides by 2. So remember, the aim is to make x the subject of the formula. So 19,47 divided by 2, that will be 9,74 plus k times 180. Right, okay. Okay, then we look where sine is positive. Remember that sine is positive on its home, it's on the second quadrant and as well as on the first quadrant. So in this case, we could say 180 minus 19,47 plus k times 360. Okay, what are we having when we say 180 minus 19,47? So which will be 160,53 plus k times 360. We are not done, so we have to divide both sides by 2. Divide both sides by 2. So the aim is to make x the subject. So what is 160 divided by 2? That will be 80, what? correct it 2 decimal places, it will be 80,27 plus k times 118, right? Where k is an element of integers. Don't forget, right, guys, to write where k is an element of integers. So that's how we can do this, right? That's how you can work out the 6 marks. Hope you saw. Right, we have already, we are now on 5.4. Well, now we are at question 5.4. Given the identity cos x plus y multiplied by cos x minus y, which is a compound angle, which is equals to 1 minus sin squared x minus y squared. Okay, that is 4 marks. So we are required to prove this identity. First thing first, choose the appropriate side that you will, that is easy for you to work with. In this case, I think that it will be nice if I can work with the left hand side, right? The left hand side. So we gotta prove the identity. Let's put this into practice. Innocent until proven guilty. Yes, at 5.4.1, we are given cos x plus y, okay, multiplied by the product of, okay, it's a product, right? Cos x minus y, which is equals to 1 minus sine squared x minus sine squared y, okay? So we have to prove. So we are working on, I'll prefer to use the left hand side, okay? So in this case, it will be, let's start with this, the positive one, compound angle. So it will be cos x as well as cos y. Since the sign is positive, it becomes minus. So we are going to have sine x and sine y in this case. Okay, put this into brackets. Let me work out the other one. This will be cos x, cos y. Since it's negative, it's going to be positive. You're going to have sine x and sine y in this case. Okay, so what are we going to do in this manner? Cos, okay, remember that there's a plus here and there's a minus. What I can see, it's sort of a difference of 2 squares. It's like having, remember in paper 1, it's like when you're having x plus 3 and x minus 3. This is a difference of 2 squares. In this manner, you will say x times x, which is x squared, and 3 times negative 3, which is minus 9. So we will do the same thing even here. Cos x times cos x will be cos squared x, and cos y multiplied by cos y will be cos squared y. So remember, we'll take the negative sign. Similarly, in this case, we are going to have cos squared x as well. We're going to have, we're going to have sine. We're going to have sine squared x. Remember, sine x times sine x and sine y times sine y. So we're going to have sine squared y, right? Okay, what is interesting is that we do have this path, which is this path. What is missing? It's this. Where will we get this 1? Okay, so to make things easier, I advise that, what about changing both of this cos squared and cos y squared and this, so that we have so that we will have this 1 minus something there. Let's remember that cos squared x, it's a square identity. So we will have, remember that cos squared x plus cos squared, sine squared x plus cos squared is equals to 1. It's a square identity. To make sine the subject, you will transpose cos, so it will be here, you'll be having 1 minus cos squared x. So if you are supposed to make cos, we are going to have 1 minus sine squared x. So for cos squared x, it will be 1 minus sine squared x. So it will be you're going to have 1 minus sine squared x. For cos y squared, you're going to have 1 minus sine y squared. Okay, subtracted by sine squared x and sine squared y. Okay, so in this manner, this is what we are going to do. Let's work out this using FOIL. 1 times 1 is going to be 1, and sine squared x times 1 is going to be sine squared x, and sine squared y times this will be negative sine squared y, and sine squared x times this will be plus sine squared x and sine squared y, okay, minus sine squared x and sine squared y. We will then look at the like terms, right? Do we have the like terms here? We do have sine squared xy. Do we have, yes, we do have sine squared xy. So meaning that this and this, they will cancel each other. This will give you 0. So in other words, we are left with 1 minus sine squared x minus sine squared y. So definitely we have proven that the left hand side is equals to the right hand side, as the question requires us to prove that this left hand side is equals to this side. So that was free 4 marks. That was a free 4 marks, right? Then I think now we will go to 5.4.2. Hence, determine the value of, meaning using this, we need to find the value of sine. So how much is net? That is 3 marks, right? First thing first, I think what we could change is the sine. We have a special angle 45. So this might be a compounded double. Let's see if it's a compound. So if it's a compound, it will be cos 45, sine 45, which will be it's the same as sine 45 minus 15, which gives you, the same as cos 45 minus 30, which gives you 15. So this is what we are going to have. Let's work out this part first in this case. Okay, remember that we are having a 5.2. So remember, it's given as 1 minus sine squared 45 minus sine squared 15. So let's work out this first. Remember that sine, I said that we will work it out in this manner. Remember, let's work out sine 15 so that we are able to work out sine squared 15. In this case, sine 15 will be sine 45 minus 30, which will give you 15. So remember the compound angle of sine, this will be sine 45 cos 30. The sign won't change, so we are going to have cos 45 and sine 30. Sine 45 using the right triangle. Using the right triangle, this is the same as 1 and 1. And here we are going to have root 2. Yes, if here it's 45 degrees, even if here it's 45 degrees. For sine, it's opposite all over hypotenuse. So we are going to have 1 root 2. Okay. For cos 30, it's still a special angle. We are going to have root 3 all over 2. Okay. For cos 45, similarly, we are going to have 1 root 2, as well as, let's see, for sine 30, we will have 1 over 2. We will have 1 over 2. So in which this will be 1 times root 3, it's root 3. 2 times root 2 times this will be 2 root 2. Okay. 1 times 1 is going to be 1, and 2 root 2 times 2 is going to be 2 root 2. So the like terms, the same denominator, we subtract the numerator. So you're going to have root 3 minus 1 all over 2 root 2. Since, remember, it's squared, so we are going to square this. Okay, what are we going to have if we square this? Let's see. We're having root 3 subtracted by 1 divided by 2 root 2. 2 root 2. Okay, you square. Okay, in this case we are going to have 2 minus root 3, 2. So the solution for sine squared 15 will be 2 minus root 3 all over 4. Okay, so that's the solution for this. Okay, that's the solution for that. That's the solution. Okay, so let's go to, let me write this in a clean page. Now we are going to find 1 minus sine squared 45. 1 minus sine squared 45, it's the same as, remember sine 45, I told you it's 1 root 2. Okay, it's 1 root 2 squared, remember, subtracted. So we are going to put this in fully now. Remember, we have sine squared 15 as 2 minus root 3 all over 4 there. So what are we going to have? What are we going to have? Okay, we're going to have 1 minus first thing, let's work it out here. So 1 squared will be 1, 2 squared 2. Okay, when squared, the root 2 will have 1 over 2. Okay, just 2 subtracted by 3 all over 4. Okay, then what is 1 minus half? 1 minus half, that's the same as half. Okay, so we have 2 root 3 all over 4. We can multiply by 2 both sides to make it in the numerator. This will be 2 divided by 4 minus 2 minus root 3 all over 4. Okay, the like terms, the denominator, same denominator. We're going to have 2 minus 2 minus root 3 there. So we know that 2 minus 2 root 3 will be same as, that won't change, that won't change. Ooh, when 2 minus root 2 there, we will have something like negative root 3 all over 4. Yes, because 2 minus 2, that will be 0, right? Okay, something like this. Yes, this is what you are going to do when we are working with SAGE. So we are going to our last question, which is 5.5. We'll start with 5.1. We have to rewrite this in a single trigonometric ratio. Wow, it looks complex. Okay, let's work it out. Okay, as I've stated, we're at 5.5. 5.5.1, we're given 16 sine x multiplied by cos cube x minus 8 sine x as well as cos x. Okay, so in this case, guys, this is what we are going to do. First thing first, we need to write the expression as a single trigonometric ratio. What we can see, there's a highest common factor in this case. The highest common factor will be 8 sine cos x in this case. Why I'm saying so? 8 sine x cos x. Let's factor out. To get to 16, we need 2. So to get to cos x cubed, we need cos squared x. Right? To get to negative 8 sine x cos x, we need minus 1. Definitely we are done in that manner. When you did this, then you are happy. Okay, let's continue. So from here, this is what we are going to do. Okay, we are going to remember that 2 cos squared 2 cos squared x minus 1, it's same it's the same as cos 2x, which is a double angle, right? So we are having we can also factor out here. When we factor out, we'll be left with 2 sine 2. We'll be left with 2 sine x, sorry for that, cos x. Okay, so also as this this is also a double angle, right? So we are going to have 4 sine 2x as well as cos 2x, right? So in this manner, we can also factor out if you want to factor out. Let's factor out. We're going to have let's factor out 2. We're going to have 2 sine 2x, okay, as well as cos 2x. Okay, so factoring out this reminds us of a double angle. So in other words, we could have this is a double angle of sine. So in other words, we have let's say we have something like this, sine 2 there, the outside 2. We have sine 2x as well as, okay, so okay, with that 2 again, I think we will have 2. Yes, we'll have something like this, sine 2x, which will be, all right, which will be 2 sine 4x. Yes, this is how we are going to work out this. So in this case, we are going to have sine 2 4x, right? Sine 2 4x. Then that's the case. That's how you are supposed to work out 5.5, right? Let's look at 5.5.2. For which value of x in the interval x, it's an element of 0 and 90, will 16x minus 18 minus 8x cos have its minimum value. So when when we are supposed to draw this, remember it's 90, it's 0 to 90, so it's somewhere here. When we will have a shape, I think we'll have it, okay, let's say the period here, it's okay. So in this case, since we will have it's a sine graph, right? But let's look at this, where the amplitude is going. The amplitude will be 2 in this case. So then we'll have the one that is at -2. So they're looking for the minimum value. The minimum value will be -2 in this case. The minimum value. Remember, this is max and this is min. So yeah, you can also think of other ways that you would use to get the minimum value. But in this case, what I can see using the graphically we could see when you answer this question, you must answer it graphically. So in this case, how many marks is that? That's 1 mark. So yes, the minimum value will be -2 in this case. Or you can use other alternatives so that you work out 5.5.2. Hope you find this video useful, and don't forget to share, comment, and like. We love you.